Welcome to Study Loop.
Hi everyone, thanks for joining me today. What we're looking at is a problem of power, and what we're asked to solve for is the electric power knowing the mechanical efficiency in the SI and US customary units. So what we have is an m dot that is the mass flow rate that is moving a distance L in the horizontal direction and a distance B in the vertical direction. So what we're going to do is actually just go ahead and draw a free body diagram. And here is our mass. So we have the normal force in the normal direction. We have the weight force going down, and then we have the force that is from the motion of this conveyor belt that we're looking at. So we're also going to have this angle theta, which is defined as the angle between the direction of motion and the horizontal. And we can see that when we break down this weight force into its components, that the angle theta is right here, and W sine theta, which is the opposite, is the force that is being opposed by the driving force. So we can say that W sine theta is equal to F, and further go ahead and say mg sine theta is equal to F. Now, we know that the electrical power is equal to the mechanical power over the mechanical efficiency. We know the mechanical efficiency, we don't know the mechanical power, so that's what we need to solve for. So mechanical power is given by the change in work over the change in time, and this is equivalent to saying force times velocity, equivalent to also saying force times S over T, also equivalent to saying F over T times S. And we know this because F over T is actually equal to m dot G sine theta. Now in this problem, m dot is also referred to as m. So I'm just going to say this is equal to m G sine theta because m is a rate of mass. So this gives us that the P mechanical is simply mg sine theta times S. What is S and what is sine theta? Because these are not quantities that are given to us. Sine theta, as I said before, is the distance between, theta is the angle between the path traveled by the mass and the horizontal. And this is actually a right triangle that I'm going to draw here, and this is L, and this is theta. So sine theta is the same thing as saying opposite over the hypotenuse, so that's going to be B over B squared plus L squared. Excuse me. And this is S, which is the hypotenuse, and S is equal to the square root of B squared plus L squared. So we can see now that mechanical power is going to be equal to mg b over the square root of b squared plus L squared, because that's sine theta, times S, which is the distance traveled, and that's b squared plus L squared. These two quantities cancel, and we're left with P mechanical equals mg b. But we're not done here because we're going to actually have to look at the unit. So we see that m is kilogram per hour, as prescribed by the problem. G is meter per second squared, and B is a meter. So what we actually have to do is change this into SI units, right? So we need to change the hour to seconds, and we need to give this answer in terms of kilowatts. So we see that what we can do, we can take mgb and multiply that by 1 hour over 3600 seconds, and multiply that by 1 kilowatt over 1000 watts. And what this gives us is essentially mgb kilowatts all over 3.6 times 10 to the 6th. And this is our mechanical power. Now we're asked for electrical power, so we say that P electrical is equal to P mechanical over efficiency eta. And just by simplifying what we have here, I'm just going to bring the 10 to the negative 6 to the top. What we're left with is mgb 10 to the negative 6 all over 3.6 times eta is equal to the electrical power. And that is our electrical power requirement in SI units, expressed in kilowatts. We're also asked to do this in terms of US customary units, and we're asked to give that in horsepower. So we're going to follow the same process that we did, and we're going to now do this for US customary. So we're going to do force over time, again, because force over time times S is equal to power. So we know that force over time is going to be the same. It's going to be the weight. It's going to be weight times sine theta, which we remember as B over the square root of B squared plus L squared. And remember that this is actually in tons per hour. So this is in tons per hour. And what I want to do is change this to pounds per second. So there are 2,000 pounds in a ton. So 2,000 pounds per ton, and then 3,600 seconds in an hour. So you can see these units canceling out. And what we're left with is that force over time is equal to 2,000 over 3,600 weight times B over B squared plus L squared pound force over S. Now we have to remember that power is equal to F over T times S, which is the distance, and we know that S is the hypotenuse, so L squared plus B squared, the square root. And we can go ahead and plug in the quantities that we know for here, so we can go ahead and say that WB over 1.8 pound force per second times 1 horsepower over 550 pound force per second, and that is equal to WB over 1.8 times 550. Now that is our mechanical power. Our electrical power is going to be P mechanical over our mechanical efficiency. We know Pmax and we know eta, so that is going to give us WB over 1.8 eta times 1 over 550 horsepower. And that is our final answer.